One more example involving the interval of convergence. We see here now we have negative 1 to the nth over n times 4x plus 3 to the nth power. Just like before, ratio test to get us going. So we have the limit as n approaches infinity, absolute value, negative 1 to the n plus 1th power over n plus 1. And then the 4x plus 3 is also to the n plus 1th power. All right, that's a 3 right there. Okay, and we're going to multiply that by the reciprocal, which is n over 4x plus 3 to the nth times negative 1 to the nth power, and that limit must be less than 1. Okay, so what can happen? Just like before, this 4x plus 3 to the n plus 1 becomes 4x plus 3 to the nth times 4x plus 3 to the first. And that allows us to eliminate the 4x plus 3's to the nth. And we can do something similar with the negative 1n plus to the n plus 1 rather. This is negative 1 to the nth times negative 1. All right. Well, the negative 1 to the nth wipe each other out. Guess what the absolute value does? It's the negative 1. Bingo. Okay. So what's going on? We have the limit as n approaches infinity. We have n and n plus 1, which are positive and are no longer in there. Absolute value wipes out the negative 1. And so we are looking at 4x plus 3, and that's less than 1. This limit, just like before, is equal to 1. So we have 1 times our 4x plus 3 inside the absolute value, so that means it's less than 1 or greater than negative 1. Now we can subtract 3 and divide by 4. When we subtract 3, we have this situation. When we divide by 4, we see we have negative 1 is less than x is less than negative 1/2. All right. So our radius is rather small. All right. We're only talking about a very small radius. Here's our interval as well, and we need to check our endpoints. Okay. So if x equals negative 1, well, we're going to plug in negative 1 for x. And it means right here we have negative 4 plus 3, and that is going to give us 1. All right, so we have negative 1. So we have negative 1 to the nth power. Negative 1 to the nth power times negative 1 to the nth power. What happens if we have that? All right, let's do this again. We got the sum as n 1 to infinity. We have negative 1 to the nth times negative 1 to the nth over n. All right. Well, technically we have the same base, so we can add our exponents. So this is negative 1 to the 2nth, or negative 1 squared to the nth power. So what we're basically looking at here is negative 1 squared is 1. This all wipes out to a 1 right there. So we end up having 1 over n. That's the harmonic series. It diverges. So we're not going to include negative 1 in our interval. All right. However, if x equals negative 1/2, all right, if x is negative 1/2, well, right here, that means we have negative 2. Negative 2 plus 3 is 1 to the nth. So we have the sum n is 1 going to infinity. We have negative 1 to the nth, and then we have 1 to the nth all over n. All right. Well, 1 to the nth, that's just 1. Anything times 1 is itself. So we have negative 1 to the nth over n. That's the alternating harmonic. It converges by the alternating series test. So therefore, we want to include negative 1/2 in our interval.